And this is Mr. Preston back with Special Right Triangles Part 2. Before we move on to the other type of special right triangle, I want to talk about 45, 45, 90s a little bit more. Okay, let's say we have a problem like this, where we have a fraction as one of our legs. Okay, so first of all, how do we know that this is a 45, 45, 90? Well, it has two equal sides. So if it has two equal sides, it's going to have two equal angles. 180 degrees in a triangle. This is 90, right? So if this is 90, 180 minus 90 is 90. It's going to have the split evenly. This side goes to this angle. This side goes to that angle. So each of these is 90 divided by 2, or 45. Bam. So I should know right off the bat this is 6 squared root 5 over 2. And I want to find out what this is. A couple of ways to do this. Hopefully you've gotten to the point now where we can see if we're going to, with 45, 45, 90s, if we're going to multiply or divide by the square root of 2. Because that's pretty much all there is to it. So if I have a leg and I want my hypotenuse, I multiply by square root of 2. If I have a hypotenuse and I want a leg, divide by the square root of 2. Another way you can think about it is this side going to be bigger or smaller than these two sides? It's going to be bigger, right? So all you got to do is multiply by square root of 2. All right, then let's see this. So if you want to remember hypotenuse equals leg times the square root of 2, fine. Or if you just know, all right, leg to here, I'm going to multiply by square root of 2. 6 square root of 5 over 2 times the square root of 2. All right, so this right here actually is 6 square root of 5 over 2. This right here, 6 over 2, we're going to get to that in a second. That just simplifies to 3. But this becomes 6 square root of 5 over 2 times square root of 2. I just multiply across. This is equal to 6 square root of 10 over 2. And 6 divided by 2 becomes 3. So this is 3 square root of 10. So right here, 3 square root 10. Pretty straightforward. Now, a lot of people think that you have to multiply the top and the bottom by the square root of 2, but that's only if we're trying to get rid of the square root of 2 in the bottom. All right, so that's 45, 45, 90. Just wanted to show you one more example. Let's move on to something else. Let's move on to, let's figure out what it is. So I'm going to erase this up here. So I don't, let's see. Let's say I have an equilateral triangle, right? All three sides are the same. All three angles are the same. 180 degrees in the inside of a triangle. So each angle is 60. Let's say these side lengths are 4. 4, 4, and 4. If I draw a perpendicular bisector from this vertex to the midpoint of here, the opposite one, or if I just draw a bisector, I'm going to cut these angles in half, or cut the 60 in half, right? So this becomes 30 and 30. So there's 180 degrees in the triangle. I have two little triangles here, this one and this one. 30, 60, 90. 30, 60, 90. And there we go. That is how a 30, 60, 90 triangle is formed. So what? Well, this side length down here was 4, right? Well, it's being cut in half. The whole thing is 4. This part is 2. Let me write this a bit bigger. This part is 2, and this part is 2. Okay, can we find out this right here? Sure we can. Before we get to it, I want to go over some terms. This right here is still my hypotenuse. Before we just had leg and leg, because it was isosceles, the two side lengths were the same. Now I'm going to have different types of legs. I'm going to have my short leg, put right here, short leg, and here I'm going to have my long leg. Okay? So short leg, so hypotenuse and short leg. Hypotenuse is 4, my short leg is 2. So what you should be able to see here is the hypotenuse equals the short leg times 2. All right, so now this is basically what I have here. This is 2, this is 4, 60, and 30. Okay, I want to find out what this is. I can use my Pythagorean theorem. So I have 2 squared plus b squared equals 4 squared. So 4 plus b squared equals 16. b squared is 12. And how do we break down the square root of 12? The square root of 12, square root of 4 times the square root of 3. I have 2 square root 3. So this side length over here, this becomes, where the question mark is, this becomes 2 square root 3. But what you'll notice here is after you do this a couple of times, you'll notice a pattern. So this is the proof of it. So when you take the SAT, the other thing that you'll be provided with is for a 30, 60, 90, 30, that's crazy right there, 30. So for a 30, 60, 90, this is what you'll have. This is 30, this is 60, I don't like that. That's a little bit better, I think. So 30, 60, 90, you'll get a picture that looks like this. This will be 2x, this will be x, this will be x square root 3. Okay? So let's solve some problems using this pattern. And let's talk about this pattern a little bit. If I am given my short leg and I want my hypotenuse, so this is my short, this is my this is my long leg, and this is my hypotenuse. Sometimes people get this confused though. This is long leg, so the longer of the legs, not the longest side. The longest side is still the hypotenuse. Okay? All right, so let's say we have, okay, let's call this my 30-degree angle, my 60-degree angle. Let's say that this is 6. So my short leg is 6, right? My short leg is 6. X is 6, right? My hypotenuse is 2 times that. So hypotenuse equals short leg times 2. So my hypotenuse up here is just 12. My long leg over here, so long equals your short times the square root of 3. Well, my short is right here, which was 6, right? So this right here is going to be 6 square root 3. These two I'm going to leave up here. And that's really going to help us as we move forward. Okay? Let's change this up a little bit.